So last time we ended up with this beauty loaded from the OBJ file, and this has a bunch of problems here, right? First, the texture is all wrong, and second, yeah, the X-ray issue. So let's actually fix all this. First, maybe let's move it a little bit to the bottom and maybe a bit further away. We have this model matrix here that includes translation and rotation. So let's maybe move it like 1 meter to the front and maybe 1 meter down, just to have a better look at it. So the problem with the texture is, of course, that we are still using our cobblestone texture, right? This one that we use for the text squad, and instead we should use our color map that comes with the model. So yeah, let's change that here and take another look at it. And it still feels wrong. And the reason for that is that in our OBJ file here, the y coordinate is actually inverted. It starts from the bottom. So instead of 0 coordinate being at the top and 1 being at the bottom, it's inverted. So 0 is actually at the bottom and 1 on the top. And I think this depends on the export settings in the 3D software. But since we have it like this with this particular object, we need to invert either the addressing or the pixels. So with pixels, we could do in STBI with a simple setting before we do the loading. So in STBI, there is a function called set flip vertically on load, this one, and that takes like 0 or 1 because it's C API. So if we put 1 here, it will look much better, right? Like the headlights are on the proper place and the wheels are looking more or less correctly, right? The license plates and whatnot. So this one way to fix this. And the other way to fix this is actually just change our UV addressing here. So here we get the UV coordinates directly from the OBJ data, but we can actually transform it like this. Let's introduce a local variable UV, and now when we actually create the vertex data here, we use the X as is, but Y we invert using 1 minus UV dot Y, because the texture coordinates are of course normalized, and if we want to invert the value from 0 to 1, we can just say 1 minus that value, and that will give us the same effect. Now getting rid of this X-ray effect is a little bit more involved. So let's take a look. We have this projection matrix, right? If you remember, I talked that the projection matrix basically transforms our world coordinates into the clip space coordinates. And the clip space is actually not just our screen values, right? It's not just the -1 to 1 in each direction on the flat screen plane, but also it has some depth. So this near and far clipping planes are actually mapping to the depth values in our clipping space from 0 at the camera to 1 at this 1000 meters. So 1000 meters will become like 1 in the clip space. And this is what is called a depth. And basically all the vertices, all the coordinates that we pass to the pipeline have also the depth kind of coordinate in the clip space. So the problem is that currently these depth coordinates are not really used at all. And when we are drawing our triangles, our primitives, we don't really care if something that was drawn before on the screen should actually be in front or behind what we are about to draw. We just draw. But this is something that we can control actually from our rendering pipeline. And if we take a look at the graphics pipeline creation information, there is this depth stencil state field that contains this structure. So let's maybe add it somewhere here next to the vertex input state and start initializing it. Now, why is it called depth and stencil? Well, basically depth and stencil are similar but different features, but they are often combined because their purpose is kind of similar. They basically decide whether some pixel, some fragment should be drawn on the screen or not. And we will not cover stencil for now. Basically this is something for like masking and maybe some advanced features. we will only care about the depth, so we can safely ignore everything that mentions stencil here. So that leaves us with these three fields: enable depth test, enable depth write, and the compare op. So basically what we want to do is when we draw the pixel for the first time, we want to write its depth value into a special buffer. So this would be what this depth of write field controls. And then when we draw again at the same coordinate, we want to actually read the value for this coordinate in that buffer and do a test and decide whether we want to draw the pixel or not. So this would be the second field, enable depth test. And the third field is basically the operation that we use to make the decision when comparing two values of the depth. So when comparing the previous value of the previously drawn pixel in the buffer and the depth value of the pixel that we are about to draw. So this would be our compare operation, and this is simply less or equal or less or equal or greater, so basically just a number comparison. So again, each pixel has its own depth value based on the actual real world depth value, so the 3D coordinate. And when two pixels are on the same screen coordinate, we can actually compare their depth values to decide which pixel should overdraw which other pixel. So with that in mind, let's enable the depth testing. Let's enable the depth writing. And for comparison, because we know that the pixel on the far clip plane have the clip space coordinate of 1, and the pixels that are close to the camera have the depth value of 0, basically the smaller depth value the pixel have, the closer it's to the camera, and that means that it should overdraw whatever was drawn before. So the pixels that are closer to the camera and have less depth value always win. So that means that the compare op should be less. Now with this, we defined a pipeline behavior regarding the depth testing and depth writing, but we still need to actually create the buffer where the values will be stored and actually attach it to our pipeline. And the depth buffer is actually just a simple texture of a special depth format. So it is actually created exactly like a normal texture, like we do here, for example, for our texture that we use for the model. But instead of the color format, we are gonna be using a special depth format. And the width and height will be the width and height of our render target, which in our case is our screen. So everything else is actually exactly the same. So let's maybe just copy paste this. Name our texture something like depth texture. And the format, if we take another look at the formats, there is a special section with depth format. So again, with this unorm, meaning the values from 0 to 1. The other ones I actually don't really know where they are used, so this leaves us with these two that I know. And this 16 or 24 basically means the precision, so 16 bits for the number or 24 bits for the number that we're gonna store. And of course, the more precision, the more space it will take, because each pixel will have 24 bits instead of 16, but also the precision will be better, so you will see less artifacts when some pixel that should be actually in front gets behind, and vice versa. So let's use the D24 unorm format. The usage is actually not a sampler, but in this case it's the depth stencil target usage hint. And for the width and height, we are gonna be using the window width and height. Our window is not resizable. That means that it's gonna be fine. We can just use this get window size that we used for our projection matrix. Let's maybe move it before we create a depth texture, so somewhere here, and simply just reuse, so win size and win size here. Of course, if you want a window to be resizable, you will need to recreate this depth texture, unless I don't know something and maybe there is a better way to not recreate the texture and somehow resize it. I'm not sure, but this is what we're gonna do. Now, just like with our swap chain texture, we need to describe it as a target in the pipeline. So here we have our target info where we describe the color target and we specify the format for the swapped chain texture, so for the color output target. If we take a look at this target info, it has additional fields about the depth stencil target and the format of the depth stencil target. So this is something that we need to specify here. There can be only one depth stencil target, so we say has depth stencil target, that is true. And the format should be the same as our texture. So maybe let's move this into a constant, something like depth texture format, right? And then we can just use it like this, but we need to qualify it. So GPU texture format D24U norm. So this would be our depth texture format. We use it here and we use it here. Now if we try to run this, the pipeline will actually complain that we specify that we have the depth and stencil target, but we actually do not bind it. And if we go back to our begin render pass, here we are providing some target information for the color target, where we specify our target texture as our swap chain texture, but here we have this nil value, and this is actually a value for the depth stencil target information, which is optional. But since we are gonna use the depth and stencil target now, we need to specify this. So maybe let's create another local structure, something like depth target info, which is gonna be SDL GPU depth stencil target info. And if we take a look at the definition, that is very similar to the color target info. So that needs a texture. That would be, of course, our depth texture. Then the store and load operation. So the load operation is what is gonna happen when we load this target for the render pass. And we want to clear it because we are starting to render a new frame with this pass. And similarly to the clear color that we are using for the colors, we want to clear the depth to something. And the good value for this is 1, because if we think about this, if our depth buffer has 1 for every value, that would be the same value where we clip all our pixels that we don't want to draw, right? This is our far clipping plane. So basically everything that we actually want to draw will have a lesser depth value than 1. And with our compare operation that we defined earlier, which is less, basically everything that is less than 1 will be drawn, which is exactly what we want. So this is fine. And for the store operation, I think we can actually specify that we don't care what happens with that, because it's not really used for anything other than just testing during the rendering. So we don't need to store it, so we don't care what happens to that, and hopefully the GPU will optimize its usage somehow. Now we simply pass the pointer to the structure to the render pass, compile, and look. Now it's perfectly depth tested. That is really cool. Just to be sure, we could maybe check some other models to see if they work. So in the Spark by Kenny, there is actually a very funny model called Tractor Police. So let's maybe check it out. And yeah, basically we will just simply load it instead of our sedan sports here. So let's just try to run it and look, a police tractor, yay! Yeah, I think that concludes the OBJ loading, the very simple one. Of course, it's very primitive, you can expand on that. Yeah, hopefully next time I will get to the camera movement and we will walk around this beautiful police tractor. Stay tuned.